And then lastly, we have modeling with graphs and tables. So the table below describes the high temperature of the first 4 days of January. Graph the points from the table below, label and scale the graph appropriately. So let's see, this will be days. And remember, it's the first 4 days of January, so the start of the year. I'm going to space them out since we only kind of have 4. So 1, 2, 3, 4. And then for temperature, we have to get from 34 to 52. So I'm going to go up by 2s, and what I'm going to do is I'm going to skip the first 30 values. So this little thing right here means like I'm skipping a bunch of values. And I'm going to start with 30. See if that'll be enough. 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56. So yeah, that's going to work out good. This is the high temperature. Whoops. That's in Fahrenheit. Okay, so we're going to graph on day 1, it was 52 degrees. On day 2, it was 46 degrees. On day 3, it was 40 degrees. On day 4, it was 34 degrees. So there are the temperatures. And so can we connect the dots on this or not? Well, let's think about this. There's a couple ways to sort of answer it. Can you have a half a day? Can you have a partial day, 1.1 days? Yeah, you can. And can you have a temperature that's not a whole number? Can you have 42.7 degrees? You can. So if you connect the dots, you can make an argument for that. I'm going to say no because I'm going to say that they only are reporting the single high temperature, right? So it's the highest temperature of the day. There's only one of those per day, and that's it. So I'm going to argue that this should stay without connecting the dots, okay? So does this data represent an arithmetic or geometric sequence? It's arithmetic. I can tell that from the graph mostly because it's linear. But I'm going to say because of the table, I keep subtracting 6 each time. All right, so there's a constant difference there. So I say because there is a constant difference of -6. Is this data linear or exponential? Why? The data is linear because you could say a couple things here. I'll say because it has a constant rate of change of -6 over 1, or that's just -6. Right? Because if I look on the table, I go down 6 on the y's. My change in x is +1, +1, +1. So if I make my rate of change, remember that's change in y over change in x, I'm going to get -6 over 1 each time. Another reason you could tell is because the data on the graph makes a straight line. If you were to connect the dots, they're all collinear points. Predict the temperature on the 7th day in January. Explain or show how you arrived at your answer. Well, there's a couple ways to do it. If I just continued the table, on day 5, if I subtract 6 again, it would be 28 degrees. On day 6, if I subtract 6 again, it would be 22 degrees. On day 7, if I subtract 6 again, it would be, what, 16 degrees. So I can do it that way. You could look at the graph and just continue the pattern with the graph. So I would go down another 6, 1, 2, and then over 1, and then so I would be at 28, and I would just do the same thing essentially. You could come up with the equation for the line and substitute it in, but our prediction is going to be 16 degrees on the 7th day of January. I continued the rate of change for a couple more steps. Oops. Or iterations. Having trouble spelling. And that's it.